In this video, we will be covering the law of cosines. So in the previous video, we saw this list of the four cases given, or four cases that we will encounter for solving a triangle, specifically an oblique triangle, a triangle that does not have a right angle. What we saw was case 1, we solved with the law of sines, case 1 and 2, we used the law of sines to solve those triangles. Case 3 and 4, we're going to solve with the law of cosines. So we'll be looking at when we have two sides and their included angle, so side, angle, side, and then when all three sides are known, side, side, side. So let's come up with a proof for the law of cosines. We have triangle ABC in the xy plane. Point A is at the point 0, 0 in the plane, so that's that point right there. This point, well, that distance is C from the origin, so we're going to say that point is C, 0. And then what we'll do is, if we drop an altitude to make this a right triangle, let's call that distance Y. Now, if we wanted to find this point where angle C is, well, C, that's just going to be the x-coordinate and the y-coordinate. Well, the x-coordinate is right here, and that length in the triangle, well, if I take cosine of angle A, cosine is adjacent, so let's call this x here. So that's adjacent over the hypotenuse, which would be b. So x here is going to equal cosine of A times b. So b cosine of A. And then if we want to find this height, right triangle, let's call it y, we would say sine of angle A is equal to y over b. So b sine A is equal to y. So these 2 points, or these 2 coordinates, we're going to use up here for angle C. Alright, now what we're going to do is we're going to find the distance between angle B and C. Okay, so we're just going to use the distance formula, and we're going to call that distance side A here. Alright, so we would have A is equal to, remember, the distance formula is the difference of the x-coordinates squared plus the difference of the y-coordinates squared. So the difference of the x-coordinates, we're going to say b cosine of A minus c squared plus the difference of the y-coordinates, we're going to say b sine of A minus 0 squared. Okay, so we're going to do some simplification here. I'm going to square both sides, so I'll have a squared. We'll remove the square root sign, and then I'm going to expand both of these. Alright, and then at this point what I'm going to do is these 2 terms, I'm going to factor out the b squared from both of those. We're left with cosine squared A plus sine squared A minus 2bc cosine A plus c squared. That's all equal to a squared. And what we notice is that this right here, that's the Pythagorean identity, that is equal to 1. So what we end up with is a squared is equal to b squared. I'm going to write the c squared next to it. So b squared plus c squared minus 2bc cosine of A. So that is the law of cosines. Now, there are 2 other versions of this, and they kind of follow the same pattern. So we would have b squared is equal to a squared plus c squared minus 2ac cosine of b. And then the third version we're going to say is c squared is equal to a squared plus b squared minus 2ab cosine c. So there is the law of cosines, all three versions. Now, one thing to notice is that whatever side is given by itself, that corresponds to the angle that we're taking the cosine value of. And then what you can also notice is that b squared and c squared, we have b and c in this term here. A squared and c squared, so we have a and c here. And then a squared, kind of running out of room here. We have a squared and b squared, so that corresponds with this a and b here. Okay, so case 3 involves solving a side angle side triangle. So remember, this is when we have a triangle where we are given two sides. Let's call it side A and side B, and then an included angle, so something like that. All right, so this example we have triangle ABC, that we have side C and side A. So C is here, A is here, and then angle B is over here. So I'm going to set this up just like we did when we were solving triangles using the law of sines. I'm going to make a little table here and filling in the values I know. So side C is 25 inches, side A is 15 inches, and then angle B is 60 degrees. Okay, so if we get a question like this and we're unsure whether to use the law of sines or law of cosines, you can just try either one, and you'll see that the law of sines is just not possible. So remember, the law of sines, we need a side and its corresponding angle. Now, in what we're given, we do not have a side and its corresponding angle. So if we were to set this up using the law of sines, well, if I had sine of angle A over 15, that's equals sine of 60 over B, I cannot solve this proportion because there are two missing values, angle A and side B. Similar, if I did a similar thing with angle C and side C, I'd run into the same problem. So this is what I meant earlier when I mentioned it's not imperative that we memorize what situations or what cases go with each law. If you try one law and you come up with two missing values in your equation, you're not going to be able to solve it. Alright, so we know the law of sines isn't going to work. Let's use the law of cosines. What I'm going to do is I'm going to solve for side B first. And the reason is because angle B is going to go into, I'm going to use angle B. So I'm just going to write out the law here. B squared equals A squared plus C squared minus 2AC cosine of angle B. So plugging in what we know, we're going to solve for B squared. A squared is 15 squared plus 25 squared minus 2 times 15 times 25 times cosine of 60 degrees. And again, remember to use degree mode for your calculator. So punching this all in, I guess I'll do step by step here. So multiplying everything out and then adding, we get B squared is equal to 475. So that means B is equal to 21.8 if I round to the nearest tenth. So I've solved for side B, 21.8. Okay, now at this point, I could use the law of cosines again. However, it's usually a good strategy to go ahead and use the law of sines. The law of sines is a little bit simpler, and now we can use the law of sines because I have one set of values that where I have the angle and the side. I have both B values. So using the law of sines, I'm going to solve for, let's do angle C first. Sine of angle C over 25 is equal to sine of 60 over 21.8. So sine of C is equal to 25 sine 60 over 21.8. Sine of C, I get 0.9 9931. So I need to use the inverse. And we get 83.3 degrees. Now at this point we are taking the inverse, so you may be thinking, well, are there two possible triangles here? Well, there's not, because the simple way is that this is not side-side angle. That's the only instance when we have the ambiguous case, when we may have two possible triangles. But if we look at the two possible triangles, well, we found 83.3 degrees. That's for angle C. So that's 83.3 right here. And we already know that this is 60 down here. Well, the other possibility where sine is equal to 0.9931 is 96.7 degrees. Well, that's going to mean that this triangle has an angle that is greater than 90, and that would mean that this, that would mean that this angle in here would be 96.7. Well, the problem is if we have this, if we have the triangle angled kind of backwards like this, this side A, which was 15 inches, is no longer going to fit in that side A. We know that side A is 15 because that's what's given to us. So I don't know if this, hopefully you can see what's happening here. The easy way to see this, though, is that if we do not have side-side angle, we only need to worry about finding one triangle. Alright, so we'll put the 83.3 degrees in here for angle C, and then at that point, once we have two angles, we know that all three angles must add up to 180, so I can just subtract from 180 and we get 36.7 degrees, and then we have solved for the triangle. Alright, so let's look at the fourth and final case, and this is solving a triangle where we have all three sides. Alright, so we're given side A, side B, and side C, and we're asked to solve this triangle. So here we don't have any of the angles, but we have side A, which is 2 inches, side B, which is 3 inches, and side C, which is 6 inches. Alright, so when we're solving a triangle when we have no angles, what we're going to do is, it's a good idea to solve for the largest angle first. And we know which angle is the largest, and that's going to be angle C, because the largest angle is always opposite the longest side. So using the law of cosines here, we're going to say 6 squared is equal to a squared plus b squared, so 2 squared plus 3 squared minus 2 times 3 times cosine of angle C. We get 36 equals 4 plus 9 minus 6 cosine of C. 4 plus 9 is 13, so 36 minus 13 is 23 equals negative 6 cosine C. I missed something here. In the law of cosines, it's, I'll just write it out. We'd have C squared equals A squared plus B squared minus 2AB cosine C. I forgot this 2 here. So that's 2 times 6, and that's going to be a 12. Okay, so 23 divided by negative 12. It's almost 2, so negative 1.91. Negative 1.91 is equal to cosine C. Now, if you were to type this into the calculator, cosine inverse of negative 1.91, we're going to get something that is an error or undefined. And again, because the reason is, this is saying, what angle has a cosine value of negative 1.91? Well, on the unit circle, cosine, the greatest negative value that cosine ever has is a negative 1, and that's over here at the 0.01. So there's no angle that has a cosine value that is greater than negative 1. So if we see something of this form, we say that there are no possible triangles. All right, and kind of intuitively, why is this true? Well, if we have three sides in a triangle, so we have one side that is 6 inches long. If the second side is 2 inches and the third side is 3 inches, those two sides, 2 and 3, are not going to be long enough to make up this distance of 6. So one thing that we can always check for is that by taking any two sides in a triangle, in this case sides A and B, if those two sides do not add up to more than the third side, then no possible triangles can be created. Okay, so let's look at another example for side, side, side. Okay, so looking at the three given sides, we have 2 meters, 6 meters, 5 meters. And we can check what we were talking about in that last example. We need to make sure that any two sides add up to greater than the third side, and that's going to happen. 2 plus 6 is greater than 5, 2 plus 5 is greater than 6, 6 plus 5 is greater than 2. So any combination of two sides will add up to greater than the third side. So setting up my table here. Alright, and then from here I'm just going to use the law of cosines, and we're going to solve for the longest side first. Alright, so we're going to say, I'll write it out, b squared equals a squared plus c squared minus 2ac cosine angle b. So this will be 6 squared equals 2 squared plus 5 squared minus 2 times 5 cosine of b, and then let's just simplify that down and solve for cosine of b. So doing so, we end up with negative 0.35 is equal to cosine of b. So we'll use the inverse. Cosine inverse of negative 0.35 is equal to b. So b here is equal to get 110.487, so rounded to the nearest tenth I get 110 degrees 0.5. So for B we get 110.5 degrees. Okay, now once we have one of these angles, now I can use the ratio of angle B and side B in the law of sines. So let's go ahead and do that. I'll solve for doesn't really matter. How about angle C? So sine of C over 5 is equal to sine of 110.5 divided by 6. Sine of C is equal to 5 sine 110.5 degrees divided by 6. I get sine of C is equal to 0.7806, let's call it. So inverse sine of 0.7806, we get 51.3 degrees. So that is angle C. And you could double check here to make sure that we don't end up with a second possible triangle. You'll notice that you don't end up with that because the other possible angle would be 128.7, and 128.7, if that was going to be angle C, well, add 128.7 plus what we already know for angle B, that's definitely over 180 degrees, so that is not possible. So that is no way there. So finding the third angle, angle A, we just add up B and C and subtract from 180, and we end up at 18.2 degrees. And there we have it. And again, we can double check to make sure that the largest angle is opposite the largest side, the smallest angle is opposite the smallest side, and then the middles line up. And we're good. All right, let's look at a couple other examples here. The first one says a roof of a house addition is being built to accept solar energy panels. Find the length of AC and the measure of angle BAC. So the first part, finding the length of AC, that is this right here. And the triangle is already labeled with angle A, B, and C. So the length of AC is the same as side B. So we need to find side B. And we need to use the law of cosines. B squared equals A squared plus C squared minus 2AC cosine of B. So we're given side A, that's 25. We're given side C, that's 18 feet. And we're given angle B, which is 55. So this isn't too bad for us to solve. A squared, that's going to be 25 squared. C squared is 18 squared minus 2 times 25 times 18 times cosine of 55 degrees. We can calculate what B squared is equal to, and that is 432.78. Take the square root of both sides, and we get a B value that is about 20.8 feet here. Okay, so that answers the first question. And then the second question asks us to find the angle, the measure of angle BAC. So that is this angle down here. Now, it may be tempting to try to use SOHCAHTOA here, but we cannot use SOHCAHTOA unless we have a right angle in the triangle. What I'm going to do is, well, I know that we found the length of side B, so I can label that in the triangle. That's 20.8 feet. So I have angle B and side B, and then I'm looking for angle A, but I know side A. So we can use the law of sines here. We're going to say sine of A over 25 is equal to sine of B, which is 55 degrees divided by 20.8. So sine of A is equal to 25 sine 55 divided by 20.8. We get sine A equal to 0.9846. So the inverse of 0.9846, we get 79.9 degrees about. And here we do not need to consider a second triangle because this triangle is already given to us. We know that there is one possible triangle. We see it right there. So when we look at the inverse sign, we do not need to consider that second possible angle. We only need to consider 79.9 here. And the last example asks us to find or to solve this triangle when we have the vertices of or the coordinates of each vertice. So if we were to plot this, A is at -2, 1, so something like there. B is at 5, 3, so maybe something over there, and then C is at 3, 6, so maybe up there. So there's our triangle roughly. Alright, so what we want to do is find all possible angles and all possible sides. Okay, well, to find the possible sides, what we can do is we can just use the distance formula in between each set of, or each pair of vertices. So let's find the distance between AC first. Well, the distance formula, we just take the difference of the x's squared plus the difference of the y's squared. So A and C, we're going to do -2 minus 3 squared plus 1 minus 6 squared. We end up with -5 squared is 25, -5 squared is also 25. So we get square root of 50. Square root of 50, that can reduce to 5 square root 2. Alright, so AC, that is the same thing as side B. So this is 5 square root 2. We can proceed in the exact same way to find the distance between A and B and the distance between B and C. Just for the sake of room, I'm going to calculate these for you. If you want to pause it now to check on your own or try on your own first, I encourage that. So AB, we get square root 53. For BC, we get square root 13. So side AB is the same thing as calling it side C. So this is square root 53, and then BC is the same thing as side A, so that is square root 13. And now at this point, we are left with a side triangle. We have 3 sides. So I'm going to use the law of cosines. Angle C is going to be the largest angle here because square root of 53 is the longest of our sides. So we'll solve for angle C first. So C squared, that's going to be square root of 53 squared minus or equal to A squared plus B squared minus 2 times A times B cosine of angle C. Squaring these, we're going to get 53, or squaring a bunch of things, we get 53 equals 13. 5 root 2 squared, well that's 5 squared is 25 times root 2 squared, which is 2, so 25 times 2 is 50. Minus, I'm just going to do this part in the calculator. Alright, and then simplifying and solving for cosine of C. Alright, so working this out, we get angle C equal to 78.7 degrees. Alright, and then from here we can use law of sines. I'm going to find angle B here, so sine angle B divided by 5 root 2 is equal to sine 78.7 degrees divided by square root 53. We get sine of B equal to 0.9525, let's call it. And that gets us, when we take the inverse, a B value of 72.3 degrees, let's call it. And again, we already have one given triangle. Even though we're taking the inverse here, this is not a situation where we have side-side angle. So only one possibility. This is not the ambiguous case. Alright, so we have 2 angles, and then adding angle B and angle C together, subtracting from 180, we're left with 29 degrees for angle A.